I worked in the chemical industry for players like Sherwin-Williams. I started with them, and then I worked for John Deere Dubuque Works. Then I had my own business for a while. Then I worked for FMC Corporation. Then I worked for Trona, which was a $250 million startup company. Interesting story with that is they gave me $1 million the first I talked them into hiring me. And secondly, they gave me $1 million the first day to build a pilot operation to prove out their new technology. In 13 weeks, make it fully operational. I had three offices in 2 states, had about 25 to 50 engineers, a whole construction crew, and a research facility at my disposal. I ended up building the plant 13 weeks, went from batch to continuous, and then at the end of the 13 weeks, I had one piece of equipment that didn't come over the ocean yet, and so it wasn't fully operational. But then I told the president of the company, you should have never built this plant. His jaw dropped, and I said, okay. The reason is you haven't sold your new product. Here you build a plant to make a product that you're not sure people are going to buy it. So I ended up marketing, doing technical marketing, and got the plant base loaded. And long story short, we proved out the process, went through 30 patents, and then ended up, actually at that point in time, he got all the oil and natural gas rights to New Guinea, which was a cash cow at that time because of the oil embargoes and that. So he said, I'm shelving this project, and I'm going to make a boatload of money so we don't have to borrow $200 million. And so shut down all the trial facilities and ended up laying myself off and got a job at the university. I figured it was a good stepping stone. I'm an entrepreneur at heart. I love working with biodiesel, and that's what led to the book. The history behind the book is we started a workshop because there wasn't enough information out there for the industry about 10 years ago. So 5 of us got together, put together a week-long workshop that if you attended it at the end, the final exercise was design a biodiesel plant. And so we've trained about 500 people in the United States, 22 foreign countries, and we really haven't advertised. And so now we're no longer doing the workshop because there's a threshold to how many people want to get into biodiesel. And so that's been the interesting history behind it. So that book is actually the textbook for the class and covers everything. Now, the reason I call this one meat and potatoes is because I want to keep it simple. I want to answer your questions so you can take this presentation in any direction you want. I've done a lot of work. I've worked in almost every state with biodiesel. I do a lot of troubleshooting of plants, feasibility studies, technology evaluation, investor advice, you name it, I've tried to do it. So I have a lot of background and experience out there in the field. 5 most important questions is what technology to use, where do I get my feedstock, and what does it cost, where am I going to go with my biodiesel byproducts, and can I make it safely, protect the environment, and still make a profit? These are the questions you should be asking yourself if you want to get into biodiesel, or if you have a plant that you're operating, because things continually change. This is just a simple diagram that shows the different parts of the process. You can do almost all this in one tank if you wanted to. So that's where biodiesel is so flexible. You can do it as cheap as you want, as long as you follow the steps and know the reaction, you can go through the process and make good quality biodiesel. Of course, if you're doing it in one tank, you're not going to be a 5 million gallon plant a year unless you have an awful big tank. So usually it's separate processes. Feel free to interrupt me anywhere during the presentation to ask questions. What technology did I use? Well, the basic technology of mixing with a catalyst and washing has been around for 45, 50 years. That whole process was developed to make glycerin for TNT back in the war days. But then you made biodiesel as a byproduct back then. Now we make it for the biodiesel. It's versatile, batch or continuous, so it gives you a lot of flexibility. That's why it's still being used today. New emerging technologies, there's always a trade-off. No matter what technology you're looking at, there's a trade-off. If you go with enzymatic, well then you're not going to get 100% with the first batch. You're going to have to do multiple stages. What about the enzymes, cost, whatever the trade-off? If it's a new cavitation type, sonic, or ultrasonic type reactor. What's the trade-offs there? There's always a trade-off. So if you understand the trade-offs, you'll be in a better position to evaluate if you want to go with that technology. A lot of times new technology is a different type of mixing. And some of them different catalysts, or not even using a catalyst, like supercritical. You don't need to add a catalyst. You take it up high enough temperatures, but those temperatures and pressures can kill you. You can't have a big reactor. It's ungodly expensive at that price or that size. And technologies from other processes. They're starting to take technologies from other processes that are out there. For example, enzymatic was used to make pharmaceutical high-cost products. Now they're looking at it for biodiesel. Costs are coming down. I evaluated a $350 million, 60 million gallon biodiesel plant. $350 million? That's because they were using the technology used to make surfactants. And so they wanted to use that technology to make biodiesel. Well, obviously they didn't get the DOE loan because I nixed it, because I said, if you're making a fuel, you don't need to spend $350 million. You can build a 60 million gallon plant for $60 million. So why spend all that money? You're doing overkill. If you came to me and said, we're going to make surfactants, I'd say, okay, now you're making a high value product, it's worth it. So there's always trade-offs. So you have to think of those different technologies. Where do I get my feedstock? What does it cost? Okay, it could be either seed or plant oil. That's the two basic ones that have always been around. You have animal fats, waste vegetable oil. Everybody's talking about waste vegetable oil. It's starting to get a little more expensive, but there's different kinds. You can get a very good quality waste vegetable oil, or you can get very, very poor quality waste vegetable oil. That makes a difference on what process you use. And the key is, look at those other ones. I've worked with a number of plants that said, hey, we can't make it. Someone's already collecting the waste vegetable oil. What else can we use? So we found other resources where people are making oil products that they're disposing of. I was telling someone, I think it was just today, there was a plant that was making collagen. They were taking pig skins and scraping it and doing all this processing to make this collagen. But one of the byproducts was the fat from the skins. And it was about 70%. They had two grades, A and B. A was about 85, 90%. The B grade was about 70%. They were paying somebody to transport it and land apply the 70% stuff, or send it to the waste treatment plant where they would use it to feed their bugs. And I said, well, why don't you take out the water and sell it as a biodiesel feedstock? At least you're not paying yourself, you're paying to get rid of it, you can make something off of it. So if you can find those type of waste products, that's where you can find your niche and really make a killing in the industry. Now, that's not good for a big plant, because usually those oddball feed streams are not that large of a feed stream. And so it's good for a small biodiesel plant operation, and that's what's good for us people, because most of us are talking small plants. No questions? Feel free to interrupt. This is just a common table, just comparing the two, if you're thinking of animal fats versus seed oils. You can see the comparison. There's a price difference, there's a sulfur difference, free fatty acid difference. There's all these things that will relate to what technology or what kind of plant you're operating with. Many times, companies will start up with a multi-feedstock plant. But to get their certification, they'll run soybean oil. It's easy. It's clean, no free fatty acids, a little more expensive, but they have good cold flow properties, so they'll start up on soybean oil, then they'll never switch to the other feedstocks, unless they're forced to. And then once they switch, then they find out, well, maybe the process isn't really multi-feedstock, or there's something else in that feedstock that causes a problem. I had one company that was starting to run this fat type feedstock, and they weren't making biodiesel worth nothing. So they gave me a sample, I went into the lab, started trying to make it, couldn't make it either. And I said, well, why aren't we making that much biodiesel? I was doing everything right, but I was only getting maybe about 80% conversion. Turned out the feedstock had a protein in it that was killing the catalyst. And so I didn't know that until I analyzed the feedstock. So when all else fails, analyze your feedstock instead of trying to work with it. And it turned out that that protein was killing it. So I went back to where they were making the feedstock, and I says, can you reduce that protein? They says, yeah, we just have to make a couple changes on the centrifuge. That then made that product able to be used to make biodiesel. The sterile glucosides is something that came up recently in the past couple years. That's the stuff that comes out when you do your cold flow filter test. It'll come out and it won't go back into solution. So some feedstocks have that, and that's a problem you have to address. Okay, what are you going to do with your biodiesel? Many times you have byproducts and that, and you have to have a plan ahead of time. I've had so many people call me up, they said, we started making biodiesel, now we have a tank full of glycerin, we don't know what to do with it. Well, you're supposed to figure that stuff out ahead of time. So ideally you want to try to figure out where your biodiesel is going to go. If you're going to use it for yourself, you're going to sell it. If you're going to use it for yourself, you have a little bit of flexibility on some of the regulations and rules. For example, you have to meet ASTM D6751 if you want the government incentives. You know, they require it as part of the regulations or the incentive package, the law that they pass, that you meet that specification. So, but if you're making it on your backyard and you're using your own vehicle, if it's slightly off spec, it's up to you. It's your engine that you may ruin if it doesn't work right. So you have to keep that in mind. Also, you have to be concerned about taxes and what the purity level of the product is. Some places require a lot more stringent ions, metal ions. Yes?
Can you talk about the chemistry of low temperature fuel properties? Is it saturation of the bonds? Is it isomerization? Is it chain length? What is the chemistry that affects, you know,
The cold flow?
Cold flow, gel point, the whole thing about low temperature behavior.
You want to sit here for an hour. I'll give you the condensed version, the meat and potatoes part of it. Basically, cold flow is controlled by a number of factors. If it's saturated, that means there's no double bonds in the chain. Then it has very poor cold flows. For example, lard, butter, they're saturated. They'll be hard at room temperature. So obviously, if your feedstock's hard at room temperature, and you make biodiesel out of it, it's going to be solid at room temperature too, like palm oil. And so you have to look at that. So it's the double bonds is probably the key effect, and that will influence that. But also chain length can. The longer the chain length, of course, the more it's going to have poorer cold flow properties. I had a good example. Mike Haas at the USDA, he made some biodiesel out of, I'm trying to think what he used. Some oddball oil that you wouldn't think of making biodiesel out, but it had such short chain lengths that when you went to test it, it actually threw off your methanol specification because those chain lengths would vaporize because they were so short that it actually came off when you tried doing a flash test, and it made it look like you had extra methanol in there, and so you'd never meet the methanol specification. So chain lengths can come into play. If you're talking about something like corn oil, a lot of people are saying ethanol plants putting out corn oil. Why don't I buy that? That has a wax content to it. That wax content, you have to take that wax out, otherwise it'll turn solid in your biodiesel. It doesn't really convert to biodiesel or to ester. It just goes along for the ride, so that when you make your biodiesel, if you don't take that wax out, so what you have to do in a biodiesel plant that makes it out of corn oil is you have to chill down your biodiesel so all the wax comes out. Or chill down your corn oil so that all the wax comes out. Now the question is, do you do it to the feedstock or you do it at the end of the process? The key there is, we usually say clean up that feedstock up front because it's going to make it easier to process it. Corn oil is probably the one exception, because if you do corn oil up front and take the wax out, one of the ways to take sterile glucosides out is to cool down the biodiesel, and then the sterile glucosides will come out and then filter them out. So if you have to do that for the wax anyway, a lot of places say, okay, we're not going to treat the wax up front. we have to do the sterile glucosides. Let's do the wax at that point too. Was there a question over here?
Yeah, you're saying cool it down so you get rid of the wax. What exactly do you, so you cool it down and then what?
Filter it.
Okay, so it's, because it becomes solid.
Yeah.
Okay. How cold do you have to get it to,
Well, I would cool it down to the same temperatures as sterile glucosides, and that'll take it out. So I'd say around 35 degrees Fahrenheit. Yes.
What if I want minus 20 for a cold flow point? You got any magic for me?
Yeah. Cool it down to minus 20. No, I'll tell you a story.
I mean, I read about a uric acid treatment one time, like 2 years ago, and they were talking about like minus 30 or minus 40 for biodiesel. And I this is like a one paragraph, maybe in the magazine a couple years ago. But I don't know if there's anything out there that's like looking favorable for us making substantial improvements in cold temperature performance.
There's additives that they talk about adding. The nuts and bolts to those additives is those additives, when you add them for cold flow additives, all they do is they act as keeping snowflakes, for example, of collecting together to make a snowball. So what they're doing is they're keeping those long chains from attaching. Those additives actually put a blocker in there so they can't actually mix together. So those additives don't take care of your cold flow problem. They just keep the big snowballs from forming. They let the little tiny crystals that might still go through the filter. So that's about cold flow additives. Now, I'll tell you a story. I had a friend in Nebraska that was making biodiesel, and she was running her Mercedes diesel on it year-round. And it got down to 19 below zero, and she was running it on 100% biodiesel. So I said, wait a minute, what are you doing? She was doing something, she was making her biodiesel, putting it in a drum, and then as the temperature outside dropped, then the crystals would come out and go to the bottom. When she filled the car, she filled it off the top layer, which all the crystals and all the long chains fell out, so the only thing that was left was the real short chains, unsaturated things, esters that would not gel. So she was doing great. Then she made the mistake of letting her husband fill the car. He stuck the pump all the way in the barrel, pumped it in the car, plugged all the lines. They had to take it to a mechanic to have him clean all the lines out. After he did that a couple times, she says, okay, it's not worth the hassle. I'll either fill the car or we'll go with regular diesel fuel. So you can do that temperature crystallization to get it out. But the reason that a commercial producer would not normally do it is because out of a 55-gallon drum, you might have 10 gallons on the top that are good down to 0 degrees in the wintertime. You're storing 40 gallons in that drum until spring comes or summer, so it doesn't make sense for most biodiesel. So they'll sell that down in the southern climate. A lot of times if your biodiesel is made out of animal fats or saturated feedstocks, it's going to have a 25 cent a gallon penalty to sell that, especially in the northern climates. Because they don't want it, because then they can blend it at a 2 or 5%. It's not going to affect the diesel fuel, but they can't go up to 20. 20 is iffy. Going any higher, you're going to have crystals and plugging of the filters. I'll tell you another quick story. I have a friend that's making biodiesel out of tallow. And he set up a business where he's going to farmers and saying, okay, I'll fill your tank. And this is northern Texas, so it does get down to 30 degrees at night. He fills up their tank and he'll automatically change their filters until it cleans out their tank. Because that's the other thing, biodiesel is a great stripping compound. So if you had diesel fuel in the tank before, there's a coating on the inside. When that biodiesel gets in there, it'll strip that coating right off and plug filters. So he alerts them, hey, until your tank's cleaned or your tractor's tank's clean, it's going to strip it off, plug filters. I'll replace the filters. And so he goes through that process. And then in the wintertime, he actually either does that temperature gradient, tries to sell them the higher fuel, or he'll go in and say, okay, I'll only sell you a B20 or a B5 in the wintertime because this can happen. So as long as you address that with your customer, a small producer has that option of being able to work with the customer and saying, okay, here's how we address that, low temperature. Great question. Thanks for asking. Okay, can I make it safely, protect the environment? You want to know the process and the chemicals. The more understanding you have of how the process works, the better you are to adjust your plant, to buy equipment, to troubleshoot problems, but also the safer. You have to know what the chemicals are. We saw a picture the other day of someone's garage up in flames. I don't know how many plants I've heard of that have had problems. I worked with a producer in Ohio that got started and sent someone in to work with a methanol tank, and that was okay, but enough methanol vapors got in the room that when they opened the garage door, the electricity from the motor sparked, blew up. So you have problems like that. You have to respect that methanol and the flammability.
Rudy, do you know what that fire was like? So the vapors filled up in the room, but it was a large room that had openings, and there was a spark that ignited the vapors. So was there just a pressure release with that?
Yes.
Or was there actually a fire?
But it was a pressure release. They didn't burn the place down because it was just vapors had escaped. It wasn't an open container.
Yeah.
So it escaped out of the tank because he was working on the tank, put it back in. Now, methanol detectors should have detected that. I'm not sure if they had them or if they weren't registering right.
Vapor detection system.
Yeah.
Tied up the fire alarm system.
Yeah. So you have to play, get to know your fire marshal too, because they have a lot to play. We've talked a lot at this conference. People say, oh geez, what do I do? Do I have to have a sprinkler system and that? What a lot of places will do is they'll store the methanol outside, and then they'll run 1/4 inch, 1/2 inch stainless steel tubing in, so they keep the amount of methanol in the building to a minimum. Because there's different criteria. If you're over 5 gallons of methanol, over 50, those have different regulations with the fire marshals. So you want to make sure that you find out what the fire marshals, what the regulations are on the state level and local level, and then see if you meet those regulations so that you can be in compliance with the law. We talked about the safety concerns of process and equipment. Make sure that you understand the equipment, how the equipment works, things along those lines. We talked a little bit about mixing. I went to Malaysia to work on help someone out with biodiesel over there. When I went over there, they said, let's make a batch. I said, okay, I'll show you how to make a batch. And he got this electric drill. And I said, no. Do you have an air motor? He says, yeah, we have an air motor. And what killed me is this plant makes sterno, which, if you're not familiar, it takes methanol, you add a gelling agent, and then you put it in a can. You go to these restaurants, you heat up these little pans with sterno, canned sterno. That's what they made at the plant. And he wanted to use electric motor to stir this, reactor. So I convinced him that that was not a wise idea. But that was an interesting project in itself. We had a great education day on biodiesel there. Palm oil is some other animal, and it's so controlled over there in Malaysia. Research, the government, environmental regulations. Remember, don't only think about the federal, the EPA, think about the local and the state ones. If I was going to start a new plant, I'd make sure I introduce myself to the local people, talk to them and say, hey, this is what I'm planning to do. Who should I talk to? Who should I work with? And a lot depends on the type of state. In Iowa, they have a one-stop for ethanol, and I think they have it for biodiesel now, where you go in, you talk to one person in the state government, and they make sure all permits and regulations are funneled through them, and you work with one person and get all that taken care of. Yes.
And I'll add on that, Rudy, that it's a lot less expensive typically and a lot less disruptive to have that conversation with the authorities having jurisdiction up front than doing it afterwards, where it might change equipment choices, or you might have to swap out equipment, that sort of stuff. So people say, do I really go and knock on the door of the fire marshal? Yes. And this would be true of co-ops as well. I mean, we've probably all heard stories of a number of co-ops that end up running afoul of regulations, either tax-wise or production-wise. It's a lot cheaper to do it up front and overcome or work with those issues up front.
And if you work with those officials up front, they'll appreciate you contacting them. They'll say, hey, they have nothing to hide.
That's right.
Whereas if all of a sudden they find out, what, you have a plant, and they're knocking on your door to find out that you're in operation, they're going to be ticked off, and they're going to find some reason to close you down.
And they don't want to close businesses down either. This is the
No.
other thing I learned in Colorado. They want you to stay open. They will help. And even though we had some real issues, and the guy before me had not talked to them and hidden stuff from them, as soon as I went into the different approach, it was again embraced and helpful.
Mhm.
And painful and expensive because we didn't do it up front.
Yeah, great comment. So make sure you contact and find out those regulations. Because there are a lot of government regulations, and not only that, fuel tax, if you're selling. If you're burning the fuel, you have to have a permit. Because I know a couple meatpacking plants that went to burn their fats rather than sell it. They made more money instead of, they had actually a chart. When natural gas prices fell this low, then they would use natural gas. When it went up this high, then they would burn their own fat instead of selling it for yellow grease. But they had to have a permit, and they had to have someone look at the boiler and say, yes, you can burn your own, fuel like that. Some problem-solving tips. I have a whole separate presentation I put on last year on how to troubleshoot your plant. So feel free to ask questions, but that's one of the important things. What do I do if I see this happen? Or this is a problem? How do I solve it? I don't know how many calls I've gotten from producers, anywhere from mom and pop operation up to the 100 million gallon plants a year that call me up and say, we're stumped, we have this problem, our fuel isn't passing, we're seeing this. And if you think it's fun trying to solve the problem, try doing it over the phone. Because you have to go, well, I'm going to ask you this question. Why are you asking that question? Well, humor me. And a lot of times it goes back to the feedstock and how they process. They changed feedstocks and they didn't realize they were bringing water into the operation. And that was changing everything, so they had to adjust for it. So it's always fun to go through that whole list and say, okay, now if you do this and this happens, do this. Okay, if this happens, do this. And go all the way down until they get confused, and then they call you back. Well, I'm down to here. Now what am I supposed to do? But troubleshooting the plant. So make sure, what goes in must come out. So you figure methanol, feedstock, catalyst, that's all going in. It's got to come out someplace in some form. So you can do your balances. You can do a water balance and say, here's how much water is coming in with my methanol. Here's how much of my feedstock. Where's it going out? And that'll help you solve and find out where there's a problem. If you're getting a high sulfur feedstock coming in, then you say, okay, sulfur is either going to go out in the fuel or the glycerin. Which is it? How do I find that out? So you can troubleshoot your plant by finding out what goes in must come out. And do those mass balances. If you have 5 pounds of water coming in, 5 pounds have to come out someplace, whether it's in the exhaust, in the glycerin, in the feedstock, in the recycle stream. Where's it coming out? Make test batches in the lab. If you're getting a new feedstock or looking at the feedstock, try it in the lab. I'd much rather see you make a popsicle in the lab in a beaker than a full reactor up that you have to chip out. So always test it in the lab. And also it'll give you some parameters that you may have to change to make it work in your plant. Make it wrong in the plant. One of the things we did in our week-long class is we had you make it wrong. We said, okay, here's a feedstock with too much water, make biodiesel. Then make it. Or here's one that has 7% free fatty acid, make biodiesel. And then when it turned into jello, okay, now what are you going to do to fix it? So once you see how it works wrong, you can more recognize it in your own process and figure out how to fix it. First check of quality is take a look at your biodiesel. You can tell a lot by just looking at it. And so that'll help tell if you're having problems with your biodiesel. Know the effects of temperature on your product, process, and reaction. Temperature is water and temperature are those tricky places. Water sneaks in all different ways. If you make your own methoxide by adding sodium hydroxide to methanol, that makes a lot of water. One time I did a mass balance, I did a calculation. I said, okay, if you buy methoxide, it's this much a gallon. If you buy sodium hydroxide and throw it in methanol, it's this much. And I figured that out, and it turned out that the price difference was so similar, plus you didn't have all that water, there was a no-brainer for me. And so a lot of times you gotta look at that and say, okay, what makes sense? How's the water affecting me? And then look at your temperature. You can make biodiesel. In fact, I was working on a biodiesel plant that was completely solar in Hawaii, where you were just heating it from the sun. Well, it wasn't getting that hot. You weren't getting up to, 65 degrees centigrade or 140 degrees Fahrenheit, which makes the reaction go quite quick. You can do it at room temperature. It's just going to take a lot longer. So by knowing how temperature affects your reaction, you can adjust your process so you can make it run a lot cheaper.
Rudy?
Yes.
So there, in chemistry, sometimes there's this saying that every 10 degrees that you raise a reaction, it doubles the kinetics of a reaction. As just a general rule of basic chemistry. It doesn't hold for any particular reactions necessarily, but do you know what that curve looks like for the transesterification reaction? So say, comparing the reaction from 50 degrees Celsius to 60 degrees Celsius, what that time difference is, or reaction time difference is. Have you done that kind of work?
Yes. There is a graph in our book, but I'll draw it real quick up on the board. Make sure I don't run out of time. And let's see, this is percent conversion time. So basically, when you start off, a lot of this has to do with reaction kinetics. How quick you mix it initially is very important, because you're mixing oil with methanol, and they don't want to mix. And so you beat the heck out of it up front. That kicks off the reaction and starts it up this curve. Now, once you do that, if you continue to beat it up like crazy, then when you get up here, you're going to make an emulsion. So you don't want to do that. So you have to play with your agitation. The temperature is the same sort of thing. As you add temperature, it's going to quicken the reaction, but only until you get to the boiling point of methanol. If you get to the boiling point of methanol, the methanol is going to evaporate. Even if you have a pressure vehicle, it's not going to, you can condense it and drop it back in, but you reach a limit of return. So once you start getting above the boiling temperature, it doesn't, you can heat it up as much as you want. You're not going to get any faster reaction. So that temperature does come into play when you're at room temperature up to about 140 degrees. Once you start getting above that Fahrenheit, then that's, it doesn't have an effect. The other thing is you start having things like here it's the oil mixing with the methanol that makes it go slow. Once it starts mixing, you make a little bit of glycerin, it helps that reaction take off like crazy. When you get to the top, you start getting the reverse happening. The glycerin's mixing with the ester and going back to triglyceride and methanol. So you have that competing reaction up near the top, so then that's where you start losing, it starts slowing up because you have a problem with the reverse reaction taking place. A good example of this, I was called to a California plant. They were having problems where they were not getting full conversion, they were getting a lot of emulsion made. Turned out that they had a 12-foot static mixer on the reactor. And that, for this part, it was great. But after you got through that, they started emulsifying. When you get that much mixing, you start having the glycerol turning into small droplets. It acts as a surfactant, and you start making this emulsion that doesn't want to separate. And so what basically I had them do is say, okay, you can run it through this static mixer for maybe 10 minutes, then bypass it. You have a pump, that's going to give enough agitation, that'll take care of it. And that took care of their problem that they had with emulsion being formed. So understanding all these parts helps you make a better process. Yes?
You think you can run a static mixer to get enough mixing to make it happen continuously?
Yes. You
Ever seen
mean,
anybody do it?
you mean continuous?
I'm talking about methanol and oil and catalyst in one end, enough static mixer that the other end is finished reaction, just flowing straight through.
No, it just
No.
goes to a different tank,
Yeah.
through the big static mixer and then into a settling tank instead of the reactor.
That's what I mean, is the reactor is just a static mixer, just finishes the reaction.
There is what they call a plug flow reactor.
Okay?
That basically you go through, it isn't a static mixer the whole time because you want small turbulence. A static mixer, if you had a static mixer that had a whole bunch of crossbars in it, so you got a lot of mixing,
Yeah.
then down the length it's maybe one, maybe none, and then just a tube for length. That would work as a, when it comes out the other end, it would be biodiesel. But you don't want to have a full static mixer.
So a full static mixer that's just a corkscrew for 10 feet of mixing tube is a bad idea.
Mhm.
But if you had, really dense and then maybe less dense and less dense.
Well, think of it this way. The reaction takes a molecule of oil, meeting a molecule of methanol, with the catalyst coming in there, making the two go together and react. You have to have those two bumping each other. So if you were just to let that tank sit, they slowly move around, they might come in contact, make biodiesel, maybe not. That's why they usually have circulation or some type of agitation to help those get together. Glycerin also plays a role in there because sometimes the catalyst loves the glycerin, so it hangs on to that. So does the methanol. So it's the glycerin with the catalyst and methanol bumping into the oil that causes the reaction to happen. So you want that, you have to have that hitting. So just going through a 10-minute static mixer or something doesn't have enough of that bumping to have everything converted. So it does take some time. Just like the people will say, my reaction takes a second. You don't make biodiesel in a second because it's going through this Venturi cavitation, whatever they want to call it. Yes, it takes a second for those two molecules to mix and hit, but what about this molecule here that never came in? I love playing with these technology providers because the question I ask them is, what does your process do that I can't get with the regular biodiesel process? What do I gain for this price I'm paying for your technology? One of my favorite stories is investors hired me to talk to a new technology provider and say, okay, evaluate this technology because it sounds great. We want to buy it. It uses microwaves. I said, okay. I went to talk to the technology provider and he said, all right, you have to sign this non-disclosure. It's okay. Let me read it. And I read it and it says, you can't talk about the filtering. You can't talk about how we clean up the feedstock. And he says, I'm not going to sign this. I know all that. Narrow it just to your microwave reactor. Oh, we can't do that. I said, okay, I'm not going to sign it, but let's talk. And if I ask you a question that you say, hey, it's proprietary, I can't tell you, fine. So I sat down, I started talking with him, and I told him, okay, you're going to have, use this much electricity, this is that. His jaw dropped. He says, how do you know that? I says, well, I know something about microwaves and ultrasonics. And so at the end there, I was saying, if the problem with your technology, you're not addressing this issue. And he blew me off. Said, oh, yeah, okay, yeah, sure. So the investors didn't buy that technology. 2 years later, I get a call from a biodiesel plant. And they call up and they say, we can't make good biodiesel. I says, okay, what are you doing? Well, we're using this technology. I said, oh, don't say no more. I know what the problem is. So I went in and looked at their plant and said, okay, here's their problem. And they said, oh, okay. Well, it turned out that they were the first plant for this new technology. And of course, everything I told them wasn't going to work right didn't work right. I says, well, shut the ultrasonics off and the microwave because they didn't have it designed right. I said, shut it off and we'll do this and go back to more of a traditional thing. They says, we have this great out that if we don't make to yield, that they'll pay us so much every month. So for the next year, they ran that plant at a reduced rate, got about $1 million from the technology provider. Then when that ran out because it hit the limit, then they said, okay, shut it off, and then they brought another engineering company and repiped it. So that just goes to show that, you have to understand your technology and how it's going to work. I love going into the plants. I love walking through plants and evaluating them because I try to find things that are problems with it. Now, does that answer your question, Jess?
Yes, so coming back to the kinetics, so about 50 years ago, together with Professor Lukenbach, we have done a complete study of kinetics. And to give it simple, if you do a reaction at 25 degrees, 88% of your oil is going to biodiesel. Also, triglycerides are easily converted to diglycerides. With triglycerides, it goes slower. From mono to the ethyl still goes slower. So the first step, the second step, and the third step is the rate limiting. It goes immediately to 90, as you said, on 10 minutes. Even at room temperature, but to go to 99% conversion, then we need half an hour more at high temperature.
Yeah, the key, when you get up in this area, to make it take off again, is you have to remove some of the glycerin. So that's why you have multi-stages. So instead, if you have multi-stages, you would have something like this. And then, so that you're always moving up by removing the glycerin. But of course, when you remove the glycerin, you're removing some of the catalyst, some of the methanol. Some of the other points, free fatty acid can be a problem. As long as you know it's there and you know how you're going to address it, it's not a problem, but it can sneak up on you and cause problems. Jatropha, everybody's heard of Jatropha, how great it is. When you bring that over from Africa or some other country, by the time it gets here, it's 15% free fatty acid. Depends when you pick the fruit and extrude it, you can have 15% free fatty acid. That's a problem. If you know it, then you can address it. Minimize your water in the reaction phase. That'll inhibit the reaction. Make sure you understand the process and equipment. Feedstock determines the biodiesel properties. I always thought that someone would be making designer biodiesel. You tell me what you want and I'll get a feedstock with that chain length, with those properties that then will transfer into the biodiesel. Soap production is difficult to remove, so if you can remove the free fatty acid up front, take care of it then, it's easier than trying to remove the soap in the back. I don't know how many times soap's been a problem in resin beds trying to clean it up because it turns to snot. Once you take out the methanol from the biodiesel, it comes out of solution and it'll just be stringy and cause all kinds of problems in your distillation columns, your flash tank, and your media beds. So you want to make sure you realize that and address that feedstock and soap issue. Sample and test frequently when troubleshooting. I don't know how many times someone calls me up, I have this problem. I says, okay, did you check the sample before and after the reactor and before and after settling and before and after? No. Well, you need to do that so you can tell me the answers, or at least find out the answers for yourself so you can find out what the problem is. Some final advice, details do matter. So, a lot of times when I ask questions, I'll ask a question, what's your water? Well, what's that matter? Well, this is why. And so, know all the details. Feedstock preparation is important. If you're buying or waste vegetable grease or collecting it, how you prepare it is so important. If you're trying a new feedstock, clean it up. Like the one example I gave you that had proteins in it. Who would think of looking for proteins? Or how would we affect the reaction? You only can find that out by running a sample in the lab, but that preparation of that feedstock is important. Everything in the process is interrelated. If you tell me I have free fatty acid here, I'm going to look for soap over here. If you tell me you have water here, I'm going to look at conversion rate over here. So everything's interrelated, so everything plays a part.
Wouldn't the proteins, if you did a multi-stage reaction, wouldn't the proteins settle out on the first reaction?
No, because they're compatible with the biodiesel.
Oh, okay.
They kept in the biodiesel or the oil. Ask an expert. There's a lot of resources out there. Find a resource. You can beat your head against the wall until finally you say, hey, it's time for me to ask somebody. Find out, ask a question, find somebody who knows biodiesel. Other people in this room, call each other up and say, hey, have you had this problem before? What's the solution? I love walking through plants. Last year at the conference, I met somebody, I went through their plant, and I went through the plant, I said, you do all the talking, you tell me your process. Then we're gonna go through a second time, I'll do my talking. So we walked through his process, and then I went through the second time, here found out a couple things that he could have done to improve the operation and so forth. And I come to find out, he adopted most of my suggestions. He had some equipment that he had just bought that I suggested he didn't need. Some equipment he was using one way, I said, yeah, try using it this way. And it turned out that he was going to go out of business if I hadn't walked through his plant and gave him suggestions. Now he's still doing good, which is good to hear. Yes?
I just want to second what you said about having people to talk to. There's many people in this room, get to know them and get their phone numbers. I can't tell you how many times I've had someone call me with a problem. I'll call someone in this room. I've talked to Bob numerous times. I've got someone doing this. And we've been able to solve the problem because many of us together have seen just about everything you can do. So, ditto.
Yeah, that's a key. And that's why you come to conferences like this. It works together. Know your market and customers. You're going to have to sell your biodiesel to somebody, your glycerin to somebody. Know that market, find out how it works. I had one plant that said, hey, I can't seem to buy. This was before they had the blender's credit. And they says, oh, how am I going to sell biodiesel? It's much more than diesel fuel. I said, I'll come and help you market it. I spent 2 days with them, went around, we basically sold out their plant. You have to find those markets that are willing to pay more for the biodiesel. There's, power companies that have green power. They'll buy the biodiesel to run that generator twice a year to make electricity because they have to test out the generator. Hospitals, there's all kinds of these niche markets that know your customers, know how to sell it. Do what's best for the biodiesel industry. That means keep your head about you. Don't be making it in the garage, blowing up a garage, causing a problem. You want to make sure that it's people doing stupid stuff that gives biodiesel a bad name, selling off-spec product to someone even though it's not going to plug their filters, and all of a sudden they get upset. One of the things why BQ 9000 came about was because a plant that had a mandate for B2 in the state. They made a truck full of biodiesel that was sort of off spec and it was sitting there because they were going to rework it. Someone accidentally picked it up and delivered it and it plugged a bunch of filters, and all of a sudden the state legislature said, let's cancel the mandate and all this stuff. That really hurt the biodiesel industry, and that helped BQ 9000 come about. Question?
When you're going from personal use to commercial, is it good to have a broker to deal with the taxes, or is it simple enough for that person to deal with the taxes and incentives?
It's kind of nice if you can work with a broker. If you're too small, a lot of brokers don't want to mess with you because they don't know your quality unless you're BQ 9 certified. And a lot of times you might have to go the personal marketing route yourself and figure out those incentives. It's good to know them anyway, even if you work with a broker.
But how do you collect, do you collect the sales tax or road tax, or how does that road tax get passed on to?
Yes, if you're selling it to the end user, that's the person who collects it. So if you sell it to a gas station, the gas station sells it to somebody else, it's the gas station that collects the road use tax.
Okay.
So there's, you have to read all the regulations to find out what's the best way to
If you sell straight into somebody's car, you're the one who's supposed to pay road fuel tax.
Okay, but the producer doesn't
Okay.
the producer doesn't give the sales tax. Well, it's only the person that's selling it to.
Right, but if those are the same person, if you're a co-op and then you sell to somebody who puts it in their car, you're the producer and the retailer, then as the producer, you're supposed to be paying the road fuel tax.
Just here's some of the things on the New Horizon. Some of these are right around the bend of being new technologies. I'm out of time, so small niche plants are neat. Find your niche. make money. Okay.
Excellent. Beautiful.